In this lecture, we're going to learn about reverse iterators. And these are iterators you can use to traverse your containers backwards. Suppose we have a container like this and our iterator is pointing to 11. It is possible to move through the container backwards until we hit the start element. And this is really how reverse iterators work. In practice, we set up reverse iterators by using the rBegin and rEnd method. rBegin is going to give us an iterator which is pointing to the last element in the collection. rEnd is going to give us an iterator which is pointing to the element past the first element in the collection. So it is not going to be pointing to a valid piece of data. You should know that. So you shouldn't really dereference the rEnd iterator hoping to get something valid from that, because it is not meant to contain valid data. Its main purpose is going to be checked against to know that we haven't hit the end of our collection. Another thing I should tell you is that if you increment a reverse iterator, it is going to be moving backwards. So if we have an iterator pointing to 11 here and increment it, we will get it to point to 5 here. If we increment it again, it is going to point to 17. If we increment it again, it is going to point to 5. So this is really how we can traverse our containers using a reverse iterator. Just know that if you increment it, it is not going to move to the right in your collection. It is going to move backwards because it is a reverse iterator. You should really know this. Let's look at a simple example of how we can work with this in practice. We can set up an std vector of integers, and we can set up a reverse iterator by calling the rBegin method and using return type deduction here. This is going to deduce a reverse iterator, or we can even explicitly say that we want a reverse iterator which is going to work on a vector of integers, and we can say it using the syntax like this. We can give it a variable name and call the rBegin method and store our return value in it. Once we have this reverse beginning iterator, we can set up a loop to print everything in our collection. For example, we're going to loop until the current iterator is equal to the reverse end iterator, and if we hit the body, we're going to dereference the current iterator and increment it to keep moving us backwards until we hit the start element and print it. And afterwards, if we increment it again, we're going to get our current iterator to be equal to the end iterator, and the test here is going to fail, and we're going to hit the end of our loop, and we will print the closing square bracket here. This is how these things should work. Now, one thing I want you to know is that if you compare iterators of different types, the compiler won't be able to really do that, because that's really going to be like comparing apples to tomatoes. So the compiler is going to tell you, I can't compare these two things. They are fundamentally different. So I am going to throw a compiler error, and that's what you're going to get. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is reverse iterators. We will grab the code from our template files and use this as a starting point. Let's open this up in Visual Studio Code by dragging and dropping here. This will give us our main CPP file. Let's clean it up a little bit, and we will include vector because that's what we're going to be using here. I am just going to put in the code to play with these things. This is going to set up an std vector of integers. We will put in the data, and we have different ways we can set up a reverse iterator. One way is to do auto type deduction, and the compiler is going to deduce a reverse iterator which is going to be working on a vector of integers. If we hover over this, this is what we're going to see. You see that it is a reverse iterator that is going to be working on a vector of integers, and we will get this to point to the last element in the collection. So on line 10 here, after line 10 executes, we will have this situation. We will have our iterator pointing to the last element of our collection here. And once we hit the loop here, our iterator is going to be different from the rEnd iterator, and rEnd is really going to be pointing to the element past the first element in our collection. So rEnd is going to be pointing here, and the test here is going to be successful because these two are different. So this is going to be true here. So we're going to hit the body of the loop, and we're going to dereference the current iterator and print our 10. If we increment, our iterator is going to move to 9 because if you increment a reverse operator, it is going to move backwards in your collection, if I can say it like that. So the second iteration is going to test and be successful because this iterator here is different from our end. So we will hit the body of the loop, print out our piece of data, and increment the iterator again until we move and hit the first element in the collection here. We're going to do the test, and you're going to see that the test is going to be successful because this iterator here is different from our end. So we will go in and print the 1 here and increment again. This is going to move our iterator to be to the same location as our end. Once we hit our end, the test here is going to fail because this is going to be false because now they are equal. So the test will fail and we will hit the end of the loop and we will print the closing square bracket here. This is how this is going to work. Now, it is also possible to explicitly say that you want a reverse iterator that is going to work on your container or collection type. So here we have std vector int, and we say that we want a reverse iterator, and we're going to initialize this with what we get by calling the rbegin method from our numbers collection here. And this is going to work. Either of these forms is going to work. I just want you to be aware of this. Let's try and pass this through our compiler. We're going to use GCC. The bolt is going to be good, so we can bring up a terminal window, clear and run rooster, and we will see that we will print our data backwards. And this is what we can achieve with reverse iterators. Use them if they make sense for whatever it is you are designing with C++. The last thing I want you to know in this lecture is that if you compare iterators of different types, you will get a bunch of compiler errors because iterators of different types are really different and the compiler can't reasonably compare them and give you a valid result. So for example, if we try to take a forward iterator and compare it to a backwards or reverse iterator, we will get a compiler error. And here is a simple example. We have a reverse iterator, which we are deducing with auto, but we are trying to compare this to a regular forward iterator that we get by calling the end method. If we try to do that, we will get a compiler error, and you should be aware of this. Don't try to compare iterators that really don't belong in the same bag, if I can say it like that. Let's pass this through our compiler. So let's use GCC. And the bolt is going to fail because we can't really compare these things. And the compiler error is going to be really weird and hard to understand, but this is the reason for this. Don't try to compare iterators of different types. Let's go to the top and see if we find something that actually makes sense. And we will have an error somewhere. Here we will see that we have no match for not equals operator that compares iterators of different types. I think this is what the error is trying to say here. And we're going to have a bunch of confusing lines after this. But this is the problem on line 23. We shouldn't really compare iterators of different types. And if you try to do that, you will get a compiler error. This is all I had to share in this lecture, showing you how you can work with reverse iterators. You get the starting point for your reverse iterator by using the rbegin method, and you get the ending iterator by using the rend method. And if you increment a reverse iterator, it is going to move backwards. You should really know this. We're going to stop here in this lecture. The next one, we're going to learn about constant iterators, because iterators we have seen so far can be used to modify data. So for example, after we have the beginning iterator here, we can go in and say it and dereference it and put in some data. Let's put in 34. You're going to see that this is going to work because this is not a constant iterator. And if we print our data, we won't see a 10 here. We will see a 34 in the place of a 10 because we have modified this iterator when it was pointing to 10. You should really know this. Let's pass this through our compiler to show you that it is going to work. Then we're going to move to the next lecture and show you that it is also possible to set up constant iterators that don't allow you to do something like this, or iterators you can't really go through to modify what they point to. This is what I mean. And this is a non-constant iterator by default. So let's head to the next lecture and learn about constant iterators.